In this screencast, I'm going to talk to you all about quartiles and percentiles. So what are quartiles? When an ordered set of data is divided into 4 equal parts, the division points are called quartiles. What are percentiles? Well, in general, the 100 times kth, so k is a fraction between 0 and 1, is a data value such that approximately that percentage of the observations are at or below this value, and approximately 100 times 1 minus k percent of them are above it. So for the 60th percentile, k would be 0.6, and that would correspond to the data point that has approximately 60% of the data below it and 40% of the data above it. So let's take a look at an example. This is where we might have an odd number of observations. We have a data set here, 3, 4, 6, 7, 8, 10, 11, 13, 14. So we have 9 observations. The median, which we've already talked about, can be obtained using the median function in Excel, and that's equal to 8. The first quartile, if we have an odd number of observations, which we do here, is the value of the data that contains roughly 25% of the data below it when sorted. There's 2 ways of calculating quartiles. The first is to include the median in the calculation, or we can exclude the median in the calculation. By the way, the second quartile, which is also the 50th percentile, is exactly the same as the median. So in Excel, if we wanted to compute the median, we could use all 4 of these functions: quartile, quartile inc, quartile exclusive, with 2 as the second argument, or we could use the median, and these all give the same thing of 8. So again, the first quartile is the median of the first half of the data, if we're talking about odd number of observations, but it depends on if you include the median or exclude the median. So what does it mean to include the median? If we include the median, then we're considering these numbers, 3, 4, 6, 7, 8. Then the first quartile is the median of those 5 numbers, which in this case is 6. Make note that we're talking about an odd number of observations here. In Excel, we can use those 2 functions, quartile inc or quartile, and that'll give us the first quartile if we use a second argument of 1. The third quartile, also the 75th percentile, is the median of the second half of the data. If we include the median, then the third quartile in this case, again, odd number of observations, is going to be 11. In Excel, we can do the same thing with 3 as the second argument in that function. So let me show you how we can use Excel to do this. Let's go ahead and name this data set data 1. Let's name this, I'm going to go up here and name this data 2. Our third data set that we're going to be working with, data 3. The median, we can just use the median function. So the median of data 1. Let's go ahead and compute the median of data 2 and that of data 3. So we have a median of 8, 7.5, and 9 for those 3 data sets. But we can use the quartile.inc function. Our array here is going to be data 1, and we want the first quartile, so I'll use a 1 there, which is 6, which is what we just got when I sort of did this by hand. We can do the same thing here, quartile.inc of data 1. The third quartile, we put a 3 there, and we get 11. Okay, so what does it mean to exclude the median? Again, here we're talking about an odd number of observations. In data set 1, we have 9 observations. If we exclude the median when we calculate the first quartile, we're just considering these 4 numbers, 3, 4, 6, and 7. And for an odd number of observations, the first quartile is just the median of those 4 numbers, which is 5. It's the middle value between 4 and 6. In Excel, we can use the quartile.exc function with 1 as the second argument. The third quartile, similarly, we consider the last 4 numbers. Again, here we have an odd number of observations. We're not including the median, we're excluding it. So it's the median of 10, 11, 13, and 14, which is 12. And we can use 3 in the quartile.exc function in Excel. So let's do this in Excel. I can plug in here, quartile.exc. We're excluding the median. Data set 1, our first quartile. I'm actually just going to drag this down and double click in there and edit this to be a 3. So that's the third quartile, and that's exactly what we just got when I did this by hand. Now, what about if we have an even number of observations? The median we can calculate in Excel. It's just the average of the two middle values, so it's 7.5. The second quartile, by the way, is the same as the median, so we could do the exact same thing that we did earlier. There's 4 different ways to compute the median in Excel. Now, if we exclude the median, again, here we're talking about an even number of observations, the first quartile, also the 25th percentile, is calculated as 25% between the two middle values of the first half if there are an even number of first half values. If we have 8 data points here, then the median is going to be calculated as 25% between 4 and 6. It becomes a lot more complicated if there are an odd number of first half values, and I'll show you how to do this with data set 3. So in the data to the left, the first quartile is 25% between the two middle values of 4 and 6, which is 4.5. Similarly, for the third quartile, we go 75% between the two middle values. It becomes more complicated if there are an odd number of second half values. So in the data to the left, the third quartile is 75% between the two middle values of 10 and 11, which is 10.75. So for data set 2, for the exclusive, we can do quartile.exe data 2. Our first quartile is 4.5, which is what we just got. And I can change this to a 3. So we have 4.5, that's 25% between 4 and 6. And then we get 10.75, which is 75% between 10 and 11. So now let's move on to data set 3. We have an even number of observations, n equals 10, but we have an odd number of first half and second half values, where we have 5 in each half. So if we want to exclude the median, as shown here, then the first quartile is actually not 6. It's not the median of those odd numbered values. It's not 6, it's actually 5.5. And let me show you how to do this. We're going to use this formula here, and this applies to any number of observations, whether or not you have even, an odd or even number of first half values. It works in any case if you want to exclude the median. So we're going to use this equation to determine the rank, which is k. N plus 1, n is the number of observations, times p. So p would be 0.25 for the first quartile, 0.75 for the third quartile. For the first quartile, p is equal to 0.25. So if we have n observations, we can use the formula, and we compute our rank of 2.75. Therefore, the way we can use this rank, the value of the first quartile can be found at 75%. So we kind of take the hundredths place here, 75. 75% between positions 2 and 3. So 2.75 is between 2 and 3. It's 75% between 2 and 3. So we look at our data. We find our second position of 4, our third position of 6, and we can compute our first quartile as 75% between those two values, between 4 and 6. And so we can do some math here. 4 plus 0.75 times 6 minus 4 is equal to 5.5. And that's how we can get our first quartile position if we want to exclude the median. And this, again, you can do this for any number of data points if you want to exclude the median. So let's do this in Excel. We can use the quartile exe of data 3, and we want our first quartile, and that's 5.5. I can drag this down. We can replace this with the third quartile, and that's what we get. It's a little trickier to determine quartiles by hand for data sets with an even number of observations when we want to include the median. So for data set 3, the first quartile is not the median of 3, 4, 6, 8, and 9, which would be 6.5. Instead, it's going to be 6.25. Similar to when we wanted to create a rank for cases where we wanted to exclude the median, we can come up with an equation for our rank k when we want to include the median, and that's given by this formula here. So for this data set 3, n is equal to 10. For finding the first quartile, p is equal to 0.25. We can plug those values into this formula, and we end up with a rank of 3.25 for the first quartile. The first quartile, therefore, is 25% between the third and fourth positions in our ordered list. So that's 6 plus 25% of the way between 7 and 6, and we end up with 6.25. For the third quartile, we can use P equals 0.75. We plug that in, we get a rank of 7.75. Therefore, the third quartile is 75% between the 7th and 8th position, between 11 and 13, and we can plug that in and we end up with a third quartile of 12.5. So I can plug that in here for data set 3, which is what we just did, quartile.inc data 3, 1. We can do that for the third quartile as well. Replace this with a 3, and we get what I just did using those rank formulas. Let's do this real quick for data set 2. We get 5.5 for the first quartile and 10.25 for the third quartile. And you notice that in each of these 3 data sets, there's differences in the first and third quartiles depending upon if you include or exclude the median. So if you're confused by the rest of this screencast up to this point, that's entirely fine. It all boils down to this. For determining the inclusive quartiles, you're going to use this rank formula to compute a rank. This is what the quartile.inc and quartile functions do in Excel. For determining the exclusive quartiles, we can set up this rank equation. And for both rank formulas, you use 0.25 in this formula for the first quartile and 0.75 for the third quartile. And then you just have to know how to interpret the rank and how to calculate the corresponding value between those 2 positions. By the way, we can use the same exact formulas for percentiles. We can use the percentile.inc and percentile functions to perform inclusive percentiles. The only difference here now is P can be any value between 0 and 1. It doesn't have to be constrained to 0.25 or 0.75. Similarly, we can use the exc percentile function in Excel to perform this calculation. And again, P can be anything between 0 and 1. So let's just go through an example. The 35th percentile, P is going to be equal to 0.35. If we want the exclusive percentile, so excluding the median, we can use this formula here to determine the rank. When we plug these values in, we get 3.85. Therefore, we go 85% between the third and fourth positions of 6 and 7, and we end up with a 35th percentile of 6.85. In Excel, we could just put this in, percentile.exe, the data, and 0.35. My recommendations, I think a lot of people exclude the median. I think it's more common to do that. So that's my recommendation. With large data sets, it's not really going to matter which of those is done. Quartiles and percentiles are going to be approximately the same. So that's it for this screencast. I hope you learned a little bit more about how to create quartiles and percentiles in Excel.